There's a solar eclipse coming up in less than 2 weeks now, on the 12th of August, and it will be crossing down through Greenland, crossing the tip of Iceland, down and then across Spain and ending up in the Mediterranean. So the only places you can go see this one are on a ship in Greenland. You can get to Iceland, although it's fairly limited land crossing coverage there. And then there's a great swath of northern Spain where you'll be able to see this. Now, I always think one of the coolest things about solar eclipses is Baily's beads, which is the little beads of intense light photosphere of the sun that you see at second and third contact. So I wanted to show you in this video just a few tricks on how you can hunt down locations if you are flexible on where you land for this eclipse in Spain, and there's a lot of land you can cover. You can control what sort of beads you're going to see based on the location. But how do you know what they're going to be? I'll show you. So here I am, 12th of August 26 for the total solar eclipse. I've dropped the red pin on the center line, somewhere in northern Spain. I didn't nowhere in particular, just somewhere on that center line. And here we see the enhanced solar eclipse simulator showing a corona, a photorealistic type simulation at the time of maximum eclipse, so 8:29. I'm going to expand the eclipse simulator because this is where we're going to spend most of our time. There's a simulation of the corona. It's not a predicted corona, it just looks like a corona. It's actually from 2017. If I come to second contact, you can see I have the diamond ring effect. I come to third contact, I have the diamond ring effect. I also see what looks like possibly some Baily's beads. And that's what we're going to spend our time talking about. How to find cool looking Baily's beads if you are flexible in terms of where you're going to go for this eclipse within northern Spain. Here's how you do it. I'll try to keep this as brief as possible. First of all, a few things. I want you to make sure that you have this slider cranked all the way to the right, and unless you're on an old computer, you can probably safely pull this one, which is the resolution of the Baily's beads, all the way to maximum for the best visual effects. So I'll assume you have that in place. I'm using this value up here for the solar radius, 959.95. I recommend you use that. I think it's the best value from experimental results. And so we'll run with that for today. First thing, switch to the outline or wireframe mode for the simulator. Let's just have a look at what we get. The orange line is an exaggerated lunar limb profile. So what are the valleys and mountains of the moon as they appear to us at the edge or the limb of the moon at this point during the eclipse on the path. Now, the lunar limb does change with lunar libration as the moon moves around, wobbles on its own axis, and that does affect how the Baily's beads appear, but it only changes pretty slowly. So what that means is that you can sort of recognize the same broad patterns in this limb profile no matter where you are on the eclipse, okay? If I pull the pin further down the path here, so we've gone a good few miles down the path, just watch the orange outline. It moved, but only a little bit, not a lot of change. I'll move it back up here. It moved, we're at a different time in the eclipse. But these major features are not changing fundamentally. They're moving a little bit. What about north to south within the path? If I move it down, what I'm going to do just to keep this on track, I'm going to anchor to maximum eclipse. So I'm just going to say when I move the pin, change the time to stay at maximum eclipse. That's what that does. I move it here towards the south. Watch the orange outline. Moved a tiny bit. Move it up here to the north. It moved a tiny bit, but the broad features remain intact. Now you can use that to your advantage if you are bead hunting, and here's how. What we're going to do, I'm going to clear the anchor. I'm going to come to this little diamond, which is sort of diamond ring before C2, and you can see that at this point on the center line, C2 is occurring roughly at 10 o'clock. I'll do the same diamond after C3, and you can see when you're on the center line, it happens roughly 180 degrees opposite, so 4 o'clock-ish. And you can use that to help you intuit where to go to find interesting beads. Here's how you do it. If you were to relocate northwards on the path, then the contacts will move together and they will eventually, at the northern limit, land around here at 1 o'clock. Let's just show how that works. I'm going to drag the pin up here towards the northern limit. Just go a little bit further. There we go. And let me go to 5 seconds after C3, 5 seconds before C2. So you see now that the contacts are happening in this line, whereas on the center line they were happening roughly there. Let's go to the south, do the same thing. So near the southern limit, 5 seconds before C2, 5 seconds after C3, now they're down here. So you can use that to know that moving north or south on the path, in a fairly broad region of northern Spain, it'll be broadly the same. You can determine where the contacts are going to arise. And once you know where the contacts are going to arise, based on dropping the pin, you can say, well, how do I look at this orange limb? And what is going to make for interesting Baily's beads? So that's the key thing. Once you know what makes for interesting beads, it's relatively easy to find the locations that are going to land the contacts at that point, as we've seen. So what makes for interesting beads? Here's what doesn't make for interesting beads. Stuff like that, a broad depression. Stuff like that, a broad ridge. Stuff like that, it looks interesting, but it's not varied enough. What makes for interesting beads are places like this. So lots of up and down variation in the lunar limb profile in a relatively short arc. That's what you're looking for. Now, this one here is actually quite promising. There's quite a lot of variation there. And particularly things, deep valleys, like those two there, they're relatively close to one another. Those two there, relatively close to one another. You can get things like double diamond effects. So let's see if we can hunt one of these things down. So knowing that the contact points are going to move towards here as we approach the center line, what we might think is actually, if I were to come just a little bit further north here, maybe around, what do you think about there? And then just set the time, and we've got the yellow arc is starting to coincide with this zone. Let's just pull it back a little bit and play the simulator and see what we're going to get. It's quite nice. I think it'd be even better if you went slightly further north. So I'll come just a tidge further north, back to C3. By the way, C3 prime is the limb corrected contact time. So that's accounting for the valleys of the moon. The classical, we assumed the moon was smooth times, which is what most sites will give you, is a little bit different. You can see that there's actually a little bit of light leaking through these deep valleys at that point. But that's actually, if you're interested in Baily's beads, that's sort of what you want. That's neat. Zoom in, let's watch it. Let me play that forward for you. Look at that. Lots of good separation. It evolves. It's all quick. It's over like a handful of seconds. But if you're taking a lot of photographs at high frame rate, you can get some very nice effects from locations like this. I said that some of these other areas were less interesting, and I said, for example, that broad ridge there. So let's just go and look at where that is. That's way up here, so it'd have to come further south. I'm going to anchor at a few seconds before C2. That means I can move the pin and it'll still show me the same point in the eclipse, which makes this incredibly easy to do. You can see I just need to move down there. And you know what? I'm wrong, because that ridge is not broad enough to prevent beads either side of it, which means you've got really good separation of the beads around this point. So it's worth experimenting. I need to do more of experimenting myself, I think, to hunt down some of these interesting places. Let's go back another, let's have a look, 10 seconds, and let's watch this one play out. So click play. We'll watch that. I'll zoom in. So it dissolves, it breaks, very nice. So that's super good beads there because of this ridge. Very good. That's really good. Okay. If I come up to, let's have a look, Leon. There we are. And let's look at C3 at Leon. Just happening here. It's not bad. I'll go a little bit further north, just because I want to show you what happens when you do have a sort of broad depression like this. Go to C3, play it out. Just watch how they form. Do you see how they coalesced really quickly there? So that's a little bit less interesting visually. We'll watch it once again. Tiny bit, and then they coalesce. And that's just going to dominate as a single sort of wedge of beads. One more trick. If you come down here, if you have the max subscription, click here and click Baily's Beads Analysis. And what you're going to see is this little chart, which gives you a sort of a rough count of the number of discrete arcs of beads that you might see over time. And so when you see larger values and more spiky counts, that's when it's more interesting. Let's go back to this. Well, yeah, let's go. That's not bad. Let's go there. So do you see here? The chart is saying that at this point, just what's that, three seconds before C2, we should have the best number of discrete beads. And so you can see how they form, they coalesce, they separate. And so we got good separation at this point. So we've got 1, 2, 3, 4 arcs of beads. So that's this chart here, the Baily's Beads Analysis. Another tool you can use to explore this. Let's just anchor on a couple of seconds from C2, and then let's explore some different places on the path. Let me come all the way down here again, because that was pretty cool. That is a beautiful double diamond, 2 seconds before C2, but it's not even this one has got more beads, well separated. You see how long this goes on for. That's why this is a pretty neat spot, actually. There we are. So that's what that little Baily's Beads Analysis chart tells you, is the evolution of beads over time. Come to C3, you see that's just a little bit less interesting because of this broad depression. So I'm going to revise what I said earlier. Broad depressions are not great. Broad ridges can be absolutely fantastic. So hopefully that's given you some tools to easily explore what's going to happen in northern Spain. If you are able to travel, able to choose where to go, and we have clear skies, then you could choose a location that's going to give you the most interesting Baily's beads possible, just by doing some exploration with this tool in TPE. So now you know how to find Baily's beads anywhere along the path for this eclipse or future eclipses. If this has been useful, please subscribe to the channel, and if you like the video, give it a like. Please visit app.photoephemeris.com to try these tools out for yourself, and I look forward to seeing you in the next video. Safe travels and clear skies for the eclipse.